I am in a good mood today, so I'm going to spare you with the artists and the taxing task of using basic mathematical formulas for waiting line calculations. Instead, we are going to use this calculator which does all the calculations for us. It offers these four options that you can see on the screen, but we will go with option one, which is MMC model, the M/M/C model that I have explained in the previous video. So let's do some simple calculation to understand the concept of queuing. So what I'm going to do here, I'm going to start with the assumption that I have just one server. So it's a very simple system, single line, single server, customers wait to receive the service. Customers are nice, none of them would leave the line without getting served, none of them get angry and upset and stuff like that. I am going to say that I can serve 20 customers per hour. Okay, so I have customers per hour selected here, and we will do multiple options and then record in the Excel that you see on the right side of the screen. So let's start by assuming that I have 12 arrivals per hour. In the perfect system where everything is uniform, ideally we should never have any queues because service rate, which is the ability to serve 20 customers per hour, is way higher than the service arrival rate, which is 12 customers per hour. But this is not a perfect world. This is the imperfect world where the arrival as well as service are variable. So I would calculate this for the MM1 model, and the system calculates and tells me that on an average, my customers are going to wait for 0.125 hours. I am going to put that in my Excel sheet here and see where it goes. So I have the service rate, which is going to be constant at 20 customers per hour. I have my arrival rate, which I will keep changing. At this point, the arrival rate is 12 customers per hour. My wait time in system, I'm not going to write system here, but you know it that it's the wait time in the system in hours is going to be 0.125. Wait time in the system in minutes is equal to 0.125 times 60, and my resource utilization is equal to 12 divided by 20. We will check if the answer in the calculator is correct, which is correct, 60%. You can see the row here, 60%. What am I going to do? I will try to wrap these numbers so that they look nice. All right, so I have this data here with us making it look nicer. All right, now let's suppose I change my arrival to 14. So now more customers are coming in. Very well. So when more customers come in, what happens is 14, my wait time increases a little bit, 0.1667, which if I use the same formula should be about 10 minutes. Every customer has to wait. Utilization, if I use the same formula, it is about 0.7, which if you see the calculator gives me the same answer. I increase this to 16. Tolerate me for a little bit to understand what I am doing. It tells me, yeah, 2016, it tells me that the average wait time has now gone up to 0.25 hours, which is equal to 15 minutes, and the utilization is 80%. What if I increase the flow of customers to 18? Let's do that. The flow of customer increases to 18. What do you think is going to happen? Oops, I changed the arrival rate. I'm sorry, let's go back. Arrival rate is 20, flow of customers is 18. Calculate. It says now on an average a customer has to wait 5.5 hours, and I know which is equal to 30 minutes, zero point 0.5 hours, and the zero point 0.9, the utilization 90% is given. So I'm going to do 20, 19, next. It already has calculated the utilization for me. And it says now the customer has to wait for an hour, which is 60 minutes. What if I increase this even further to 19.5 minutes? What happens in that scenario? Now the customers have to wait for a much longer time of 2 hours or 120 minutes. So as we increase our utilization, if we plot these two graphs of utilization versus wait time, I can go to insert, scatter chart. The scatter chart won't be correct. I need to change the order. I want the utilization on the x-axis. I'm going to go here and say select data. I have this data, so I'm going to say edit. The chart title is utilize wait time versus utilization. That's what I want it to be called. My x-axis is the utilization, which is this number, and the y-axis is the wait times, which is these numbers. Okay, I get this graph. I say okay, and in order to make, I just change the x-axis a little bit, and I say that I want to start it at 0.5, so I can use the entire graph real estate. All right, what is this graph telling us? As we can clearly see that if we increase at lower levels of utilizations, the customer wait time is very low. As we increase our utilizations, the customer wait time increases by a little bit, but at a certain point, the customer wait time zooms up. Now, this could be problematic. So the first thing that queuing tells us to do, just an approximate idea, it tells us to do is I have to make a choice, the choice of my business strategy. Do I want to be a high service business where customers don't have to wait? Or do I want to be a low cost business where customers would be okay with waiting to receive a relatively low cost service? So if I have to be a high service business, I have to run the business in a manner where my server utilization is low so that I can generate low customer wait times and high customer satisfaction. And if I want to generate high resource utilization, well, in that case, the customers would have to wait for long, and probably I would have to market that as a low cost service so that the customers are okay with waiting.